Welcome to Economics Malawi, Introduction to Stata Lesson 5. We are intending to introduce Stata to beginners. So in this lesson, we are going to learn how to produce a box plot. We are going to learn to produce a box plot. So I'm going to use the very same data set we've been using from the beginning. We've been using this data set, though it has now graduated after adding some variables, after merging with some other data sets. So we want to be able to use this data set for gaining more and more skills in statistics. So as part of descriptive statistics, you can understand the distribution of your variable using a box plot, histogram, stem, and leaf. But in this lesson, we're going to learn one thing, the box plot. So to produce a box plot, let's first understand our variables. So these are the variables that are contained in this data set. So we have got age, sex, weight, height, body mass index, college of a student, year of study, type of accommodation, and the grade point average of a student. Now we want to produce box plot for each and every variable if time allows us, but we are going to start with age. So the command for producing a box plot is graph box, and then you type the name of the variable. So we say graph box age, meaning that we want to produce a box plot for age. So if we press enter, we must have a box plot for age. So age of a student is in the y-axis. So you can see we have a box plot. That's why it is called a box plot. It has got a box, and this box is made up of five numbers, and it has got a whisker here and another whisker here. It has got a middle line, it has got an upper line and a lower line. So this line here is representing the minimum age of a student, and this upper line there is representing the maximum age of a student, and this is the range. From here to there is the range, and this is a median age. So the median age of a student is 25, as you can see from this box plot. And then this is the upper quartile, or it's called 75th percentile, or the upper quartile, quartile 3. And this is quartile 1, or 25th percentile. And this is the called quartile 2. The median is called quartile 2, or 50th percentile. So I've got five numbers, and that's why the box plot is called a five-number summary. So as someone who is interested in statistics, you must be able to summarize continuous variables using a box plot. And we can produce a better box plot if we disaggregate it. If we disaggregate it by something else, let's say I want to disaggregate it by sex. So I can say we want our box plot to be split into two sexes, so we want to have two box plots. So if we press enter, we can see that we now have box plots for females and males. The interpretation is the same. We've got five numbers for each box plot, and we can see the the maximum age and the minimum age for female students, and the median. So now let's interpret this box. If age was normally distributed, this box was supposed to be in the middle here. And of course, you can see the line from the maximum value to the box is longer than this value. It means what? It means our age is skewed. It's not normally distributed, it's skewed. So this one is very far from the box. This one is very close to the box. The median is here. which means now which means what? Which means data is skewed to the right. The upper side here is the right side. So we can say that data is H is skewed to the right. And looking at this box plot, we can see that from the box to this minimum line is we have got a longer line, and you can see that the median line is passing far from the middle. So we can see that from this book, we can say data is skewed to the left. This is the left side, this is the right side. So data is skewed to the left. As you can see, data is skewed to the left. So this is how you can interpret a box plot. So we can produce a box plot for GPA and see if whether it's normally distributed. So we are producing a box plot for GPA, and this is not normally distributed. As you can see, the line from there is not the same as C, and you can see that the line is not passing in the middle. So GPA of a student is not normally distributed. So, and we can say it's skewed to the right, skewed to the right. This is the right side, this is the left side. So it is skewed to the right. What does it mean when it's skewed to the right? We can say, so many of our students are below this line. Many of our students are aged below this line. So that's why it is skewed to the right. And we can produce a better box plot. We can produce a better box plot for GPA if we disaggregate it by 6. If we disaggregate it by 6 as well. So we have got GPA box plot for female students and the male students. So by looking at these two box plots, we can say that females are performing better than male students. So female students are doing better than male students. You can see the maximum GPA for a female student is far from the maximum GPA for male student, and the median GPA for female students is high above the median GPA for male students, the same as the minimum GPA for females is higher above the medium GPA, the minimum GPA for male students. But this one is skewed to the left, this one is skewed to the right. Yeah, so we now are able to produce a box plot and say something about the distribution of our variable. Let's produce a box plot. Let's produce a box plot for body mass index, and this time also we must produce it by college. So I want to produce it by college. So we have produced the body mass index box plot for each college: Bonda campus, City campus, and NLC campus. These are all the constituent colleges of Flowana. So you can see here Bunda campus students, their distribution is skewed to the right. See the campus students, their distribution of body mass index is skewed to the left. And for NRC campus, body mass index is skewed to the right. So you can be able to compare the shape of the body mass index, the minimum body mass index, the maximum body mass index at the Bunda campus, the minimum. You can see, so you should be able, and this age is outlier at NRC campus. Some student is an outlier. You can see her age is above 40, close to 50. Yeah, so we can produce more and more box plot. Let's produce box plot for GPA, this time by college. By college, we want to understand which college is doing well. So you can see that the GPA is also like that. So you can see NRC campus is doing well. The median GPA is 3.5. While Ubuntu campus, the median GPA is below 2.5. At City campus, the median GPA is close to 3. So, of the three colleges of Rwanda, we can say NLC campus is doing better, seconded by City campus, and the Bunda campus is the last. That's the goodness of understanding the box plot. Yeah, so we can produce box plot of GPA this time. I want to appreciate if college is influencing performance, so we can produce it by college. Now we are producing, we have managed to create a box plot for each college of Rwanda. So I can say that okay, we already produced this. I think this is just a repetition. Okay, so I want to produce a box plot by type of accommodation. Okay, I want to produce a box plot for GPA by accommodation. So I want to produce it by accommodation. I want to see if accommodation can affect GPA of students. So we have got two types of accommodation, on campus and off campus. So for on campus, the median GPA is 21. It's somewhere 2.6. Should be somewhere 2.6. And the median GPA for students off campus who are operating from home is above. So we can say that actually students who are operating from home are the ones who are doing better than students who are on the campus. So we are able to use the box plot to understand the distribution of the grade point average of students. You can see now the beauty of statistics. We can produce a box plot for age multiplied by weight, or for height. Let's produce for height of a student now, and see whether height is normally distributed. So for height is close to normal distribution, though it is skewed to the left, but it's slightly skewed to the left. As you can see, this line is taller than this line. So we can see. Now we want to understand it, the height by college. So we can say, we can produce the box plot, okay, of height. This time by, okay, let's produce by 6. Let's produce by 6 first. Produce by 6. So a box plot of female students showing that actually female students are taller than male students. The median height of female students is taller than the median height of male students. So males are shorter than the females. And height of female students is skewed to the left. Height of male students is also skewed to the left. The beauty of statistics. You are learning statistics through Stata. You are killing two bears at once. Okay, so let's produce a box plot for college here. Will it be meaningful? This is not meaningful, but it's a box plot of a continuous variable. So you can see some students, the lower quartile is also the maximum. The student is in the 4th year, and the minimum, the lower quartile is 2nd year. The median year of study is somewhere between 2 and 3, and the lowest student is in year 1. So there's a box plot, though it's not meaningful. So in this lesson, lesson 5, we have learned how we can produce a box plot in Stata for different variables. If you have found this video to be helpful, please look forward for the next video. Thank you.